This is the Levitating Balloons Lab by Group 4B. Our goal of the experiment was to determine the quantity of the electric charge of the two balloons. We hypothesized that because the two balloons were charged on the same surface for the same amount of time, they would have the same charges. And that would make them repel each other equally so that an electric charge could be found. After completing the lab, we determined that the charge on the balloons was 2.91 times 10 to the negative 8 coulombs. Our first model was our startup model, which showed balloon A attached to a table and balloon B moving beneath it, moving slowly closer to show the repulsion between the two balloons in the distance. Figure 2 was the system schema. It showed the charges between the two balloons and the gravity forces between the balloons and the Earth. Figure 3 was a free body diagram for balloon 1, which showed the forces acting upon it. The gravity force was pulling it down and the electric charge was pulling it upward.
For the methods, to begin, inflate both balloons approximately the same size. Label one of the balloons A and the other B. To charge the balloons, rub both balloons on a group member's head for approximately 20 seconds simultaneously. Balloon A is then taped down to the end of the table so that only gravity is acting on it. Then slowly rise balloon B from the bottom of the table to balloon A. Since both balloons have the same charge, they should repel each other. Once balloon A is parallel to the table, it can be said that the electrical energy and the gravity acting on the balloon are equal. Measure the distance of the two balloons for further data analysis. The weight of balloon A is 3.45 grams. The weight of balloon B is also 3.45 grams. The distance between the balloons in trial 1 is 1.3 centimeters. And for the second trial, it is 1.7 centimeters, and gravity equals 9.81 meters per second squared.
We used Coulomb's law equation to calculate the charge of the balloons. We assume the charges on the balloons are equal, so we can use Q squared in our equation. Also, we measured our distance r when the balloon on the table was parallel to the ground so that our electric energy is equal to our gravitational energy. This allows us to use mg on the left side of the equation. After calculating the data from two trials, we found the average charge to be 2.91 times 10 to the negative 8 coulombs. We saw that the two balloons repelled so that they must have the same sign. When the balloon is parallel to the ground, electric and gravitational energy are equal, because if the balloon was pointing to the ground, it would only experience a gravitational force acting on it, and if it was pointing up, it would only experience an electric force acting on it. We then used the concept of Coulomb's law to determine our end charges. Our average charge of the balloons was found to be around 2.91 times 10 to the negative 8 coulombs, meaning it is possible to find an object's charge. However, we may have not charged the balloons the exact same, and the balloon was attracting to the table, which are both limitations in our experiment and could have skewed our data.